Good afternoon, everybody. I'm Dennis Hirsch. I am Faculty Director of the Program on Data and Governance, which is a program of the Moritz College of Law and the Translational Data Analytics Institute at The Ohio University. And on behalf of PDG, I'd like to welcome you to our first Data Points lecture of the year. Data Points is a lecture series that we do throughout the year, and we'll have 3 or 4 of these during the course of the year. As we all know, data can create important benefits, but it can also impose important threats to privacy, autonomy, fairness, and other types of threats. And so the question is, how do we get the benefits of data while reducing these threats or risks? And that's really a question of governance. And so our program, the Program on Data and Governance, focuses on these questions of governance related to data and the data society. And we have 2 main missions. We conduct research on these topics, and we try to bring in the most interesting thinkers about the most important topics related to data and governance, and enable them to share their ideas with you. And today we're going to focus on a critical topic in our data society, which is the potential for racial bias in advanced analytics and artificial intelligence. Now, many of us have heard of implicit bias. That's the idea that we carry around with us attitudes and stereotypes that can unconsciously affect our understandings, our actions, and our decisions. And we may also have heard of data analytics and artificial intelligence, and of the ways in which these advanced technologies are increasingly being used to decide access to jobs, loans, insurance, housing, school admissions, and other important life opportunities. But on one level, we might think that the use of these advanced technologies to inform decisions could reduce implicit bias because it would lessen the role of human decision makers who hold these biases. But what if the machines, which seem so data-driven, actually have bias built into their decision-making systems? Could that be an even more nefarious and problematic way that bias could work its way into our decision-making? And that's the question we're going to explore today. How should we think about and understand racial bias in algorithms? And what steps can we take to reduce and hopefully eliminate such bias, including whether part of the answer lies in increasing the diversity and inclusion in the field of data science itself? Before introducing our outstanding lineup of speakers, I need to mention that we can't do what we do without partners. And the law firm of Porter, Wright, Morris and Arthur has been an excellent supporter and partner of ours in these Data Points lectures, and they provide funding for Data Points. Porter Wright is a forward-looking firm with serious expertise in technology, security, and privacy law, and we are delighted, that they are part of our program, that they've supported these lectures. I'm now going to introduce our speakers. We've got 4 of them, and I'll introduce them all at once, and then they will go one at a time to talk. And at that point, we'll have some time for audience questions. So if you get questions, put them in the Q&A and start to think about them now as you hear our speakers. We've got an all Ohio State lineup of speakers, so go Bucks. The first of our speakers is going to be Kelly Capitosto. Kelly is a research associate with the Kirwan Institute for the Study of Race and Ethnicity at The Ohio State University. And she holds a Master's of Public Administration at from the Glenn College of Public Affairs. Her research focuses on implicit racial bias and seeks to inform equitable policy and decision-making practices. Our second speaker will be Professor Tanya Berger-Wolf, And Tanya is director of the Translational Data Analytics Institute at Ohio State. She's a professor in the departments of computer science engineering, electrical and computer engineering, and also evolution, ecology, and organismal biology. She's a recipient of many awards and is a computational ecologist who works at the intersection of computer science, wildlife biology, and the social sciences. She's also deeply committed to the ethical and just use of advanced analytics and created a new community of practice at TDAI focused on that area. I'm very excited to introduce our third speaker, Sean Hill. He just joined the faculty of the Moritz College of Law as an assistant professor. Professor Hill's teaching and research lie at the intersection of critical race theory and criminal justice policy, and he's got a forthcoming publication that specifically examines bail reform and pretrial risk assessments that use algorithms through a critical race lens. Finally, last but not least, Christopher Stewart is associate professor in the Computer Science and Engineering Department at Ohio State. He leads the Reroute Lab, where students build cutting-edge research systems, transfer them to industry and underserved communities, and celebrate diverse and intellectually enriching backgrounds. He's the recipient of an NSF Career Award and served as co-chair of the workshop on diversity in systems research and led that workshop. So with that, I'm going to turn to our first speaker of the day, Kelly Capitosta. Kelly, would you lead us off?
Absolutely. Thank you so much, Dennis, and also to Jillian for helping put this together. I'm going to go ahead and start sharing my screen. I'm really excited to be kicking off this presentation this afternoon. So whether folks are professionals in the technology landscape or academics, or maybe you just saw, was it Social Dilemma on Netflix over the weekend, we're happy to have you here and happy to be exploring this conversation. So again, I am at the Kirwan Institute for the Study of Race and Ethnicity here on campus. And today I'm going to be speaking to the data equity lifecycle. This is part of a working paper that we're working on with my colleagues listed here, McYoung and Iego. When talking about the data equity lifecycle, I think that it's important to share more about our institute and the lens that we're bringing to it. So the Kirwan Institute is an anti-racism research institute, and our mission is to work to create a just and inclusive society where all people and communities have the opportunity to succeed. Historically, our work has been in kind of two distinct buckets here. So the one being exactly what Dennis was alluding to, that interpersonal bias or discrimination, things like our decisions, things like implicit biases or explicit beliefs and values. And the other bucket here being more around our structures, our histories, our policies and laws in that institutional side. And we really think that it's valuable to have a conversation around algorithmic bias because this lens really bridges the gaps between those two bodies of work. And it's incredibly important for how we think about building more inclusive communities versus the negative outcomes and potentially perpetuating racism into our future. So with that, I'm going to be talking, giving a very high level overview about what the data equity lifecycle is. And we're specifically focusing on the potential to perpetuate racism and discrimination. There are a lot of different theoretical frameworks and different disciplines for what we think about being the data lifecycle process, but that is the orientation for where we're bringing in our lens as an institute. So I'm just going to start off at each one of these phases. We have a lot to cover very quickly, but at the core of talking about this entire life cycle, the goal is to illustrate that, our data, our analyses, and how we use and apply them are not race or identity neutral. They're not ahistorical, and we have to consider the totality of the design and those that are involved to really understand these broader implications. So the first phase is our design, or what we're calling data prior to its existence. And this phase really sets the stage for all other potential areas where bias can emerge within the process. It's where we're determining the goals. It's what we're thinking about when human beings are infusing their values, their beliefs, and their biases into the decision-making process. So on the right here, I just have an example scenario. Many of the folks here on campus are used to conducting human subjects research, maybe doing something along the lines of surveys. And there's a variety of factors that you have to contemplate in order to push something to the implementation side. It's evaluating the goals, the availability or efficiency of your data set, the costs that are associated with it, the sample size and demographic representation. And at the crux of all of these different decisions that have to occur within the design phase, there's really a juxtaposition between critical goals. One being what is the decisions that are focused on profit versus social benefit, efficiency versus equity, and those being kind of on the idea of a spectrum of where any individual decision, where they're putting their values behind. So following the design phase, the next is really what are we inputting into an algorithm or into a model? And this is the data collection and cleaning process where we're bringing that into the life cycle. Data is being identified and recorded in a certain format. So asking what data are we using and what communities are we representing? And this question of representation is one of the key ways that we can think of bias being embedded in this particular process. Here is a quote from a report on a federal trade commission saying that the exclusion of certain often vulnerable populations are inevitable when big data is being used as a tool for social policy. And this is ringing very true right now as we're thinking of response rates for the 2020 census. Those that have historically lacked access to those opportunities, whether that be technology access, whether that be because of one's age or where one lives. We know that there's a variety of hard to count populations that aren't going to be represented within this national data set. And on the other hand is kind of the exact opposite issue is oversampling. So when we're talking about issues of racism and identity, there are reasons to oversample from those populations that have been historically left out, as we've alluded to in the prior conversation. The issue around bias is when this is happening and it's not incorporated or thought of or considered within the broader design. So a lot of times when algorithms are wanting to streamline, for example, the use of public services, the data that's being collected, especially from user experiences, such as tracking of location data when riding the bus, that is going to be overrepresenting the working poor in communities of color. And at the most extreme examples of when we have this oversampling problem is when you think of things like mass surveillance. Historically, government agencies under the guise of national security have been able to collect vast amounts of data on particular communities. The DEA in the 90s included call logs of individuals that were reaching out to target hotspot areas, those being almost the entirety of South and Central America were added to a list. So as someone with Latina heritage in having family in Colombia and Venezuela, I think that it's really important to consider all of the different levels in how our data can be extracted with or without consent or control. Beyond the data collection process, the third phase is analysis and modeling. This is what we think when quote unquote the magic happens. This is where we're applying our models, doing our computation, doing our analyses, and understanding how we can analyze that data in accordance with the goals that are set out in the first design phase. Importantly, when we're talking about algorithms or artificial intelligence in particular, this analysis process might not be transparent, what we call black box, making it difficult to uncover or address what's going on in what's going into the analysis itself. Where bias and where discrimination is occurring in this phase is really how do we equate racial identity with risk. Oftentimes algorithms are developed with the purpose of identifying risk, whether that be risk of defaulting on a loan or criminal recidivism or child welfare neglect. All of these areas we're seeing where there's the potential to kind of target at-risk neighborhoods to deliver and understand social mechanisms and services. But because the history of race in our society, our history of segregation, we know that if we're including information about zip codes and geospatial data, that those can overwhelmingly serve as a proxy for race. So even if on the surface, the data that we're using appears to be race neutral, what we're saying about these, quote unquote, at-risk communities, which are typically Black, Latino, and other immigrant communities that live there, is that these communities are inherently more risky, and by virtue, those that live there are carrying that risk. And of course, there's the analyses that just incorrectly interpret information from non-white users, such as some examples from facial recognition, but I'm not going to go too in-depth into those examples right now. So the outputs being phase 4 are what we think of as what is the product that these algorithms are producing? What is the output? So when thinking about where inequity can start to occur, it's really about how do we estimate the objectivity of what is being outputted through these algorithms. If we assume that every single process that's made its way here has that air of objectivity, has that lens of critical thinking, then perhaps we're going to assume those as being objective, but when we know in reality, that's not always the case. So here are just 2 examples of inequitable outputs from the work and research literature. Sweeney in 2013 showed that Google search results were more likely to deliver ads suggesting a criminal record when a Black name was used versus a white name. And the example of crime density mapping software were yielding greater hotspots in Black and Latino neighborhoods. So where these outputs really start to be insidious when we're thinking about the long-term impact is how they're being used and applied. So this being kind of the final phase that we're thinking about and what's really related to garbage in and garbage out. And Kathy O'Neill does a really good job of this for those that aren't familiar with her book, Weapons of Mass Destruction, underlying this principle. But in looking at those 2 biased outputs from the prior slide, when they're being applied, they have the potential to not only create and mirror the same inequity that human decision makers have, but they actually have the opportunity to perpetuate it. So the first example can confirm implicit biases from those users who don't know everything that's happening behind the process, and they're just seeing the results that are on their webpage, and to confirm that association between Blackness and criminality. In the crime density mapping software, it is increasing police presence within these neighborhoods, allowing the perpetuation of higher overrepresentation of those communities of color in arrest rates. So those are just my high level, very high level examples of where bias can start to infiltrate at multiple stages within this process. But it's also important to talk about the ecosystem that these decisions exist within. Participation and input is incredibly important for how we think through building in accountability, especially when we're thinking about those most impacted communities. Are these decisions incorporating those communities into the decision-making, into the leadership process, or are these tools simply being enacted upon them? And then, of course, the economic, social factors that influence all of us, these drivers are very important. And it gets us back to kind of full circle, thinking through the original design, intent, and goals of the development of algorithms. Right now, we know that there's a lot of private influence in algorithm development, and that is very much enmeshed with traditional neoliberal models of capitalism. So it's very important to name these assumptions if we're going to really transform our landscape in thinking about the impact of these decisions and what they have on racial and economic equity. So just the takeaways before I pass it off here is that data is not race or identity neutral. Interconnected entities at these various stages have to account for specific types of bias that can emerge along the process. This is not an academic or thought exercise. These impact real decisions from policy to administrative decisions that lead to real world inequity and discrimination. And if we're going to solve these issues, we have to go beyond simply correcting for bias as an afterthought or when this cycle comes to its fruition. We have to actively pursue equity throughout. So with that, I'm going to stop sharing my screen and turn it over to my co-panelist, Tanya.
Thank you, Kelly. and to echo, very much echo and complement the very nice overview of the cycle of data and inequity in data that you've shared. And I would like to reiterate that algorithms, and particularly machine learning, they're increasingly used to make decisions that affect human lives and entire societies, stop being an academic exercise. But yet we still don't quite, we repeatedly refer to them as black box or that magic sauce or a little bit of magic or whatever it is, but that's not magic. I mean, algorithms are a series of steps aimed to achieve a particular objective. And we design algorithms that, given an input, provide specified output. Input and output are specified, and it is the job of computer scientists to come up with the steps that match the input and the output. These are mathematical formulae. In the case of machine learning, it's algebra, which through repeated process of matching input and output pairs adjust the internal parameters of the algebraic formula until the input output pairs match on training data, and we validate them on what we call the validation sets, essentially to measure the error, and the error between what should be the output given the particular input versus what actually comes out. And then we go home happy. But notice that in all of that process, it is the specified input, so it very much depends on what the input and the objective are and how we sort of create the internal algebra to specify, to match the input and the output. And given that, when we're satisfied that the error is small enough, we go off and apply it to other data sets, whether it's appropriate or not. So there's a lot of potential for bias in the entirety of this process. When we look at the data, that input that comes in, the specified sort of input and output, there is as Kelly pointed out, there is the composition of the data, the sample, how balanced over or under sampled it is with respect to a particular set of parameters, what features, what metadata, what extra information is given around the data, and how the objectives are chosen, and whether these features are sufficient to achieve those objectives. For example, in face recognition, which has been talked about a lot, typically the algorithms for facial recognition or for object recognition, so the objective of all of these, when we specify the objective and when we measure the error, is stated as the algorithm should tell you if there is a face in the picture to put a box around that face. If there is an object in general in the picture, to name what that object is, or to characterize the overall context of that object. And so we measure errors on that, on how well algorithms achieve that objective. But there is, of course, a lot of bias, a lot of decisions that come in as the source of that data. Because typically it comes in, the data that's been used for many years are the lab members of whoever designs the algorithm, or the publicly available data sets. So for lab members, obviously, there is a huge bias for age and other demographic of who is in the computer science department graduate student. And then for publicly available data set, there are big issues. First of all, there are big issues with privacy, because this is the social media platforms that are sort of taking those. And there was a case where a mother posted pictures of her children in Illinois and forgot about those long time ago. And so they were used as part of this megaface data set, which is shown here. And but beyond privacy, there are lots of sort of decisions and constraints that come into creating this data set. It's being at the right place at the right time to even take a picture, choosing to share it publicly on a particular social media platform. There's lighting and context of those pictures. And then when the algorithms are trained, and even if they perform well on those data sets, they are not intended to be applied on surveillance camera images in crowds in different countries. Similarly, if we look at very near and dear and timely right now, and probably most of you are familiar with this picture of the COVID-19 dashboard on the Ohio Department of Health website. The data that about COVID prevalence and COVID cases varies wildly by country and within US, by state, by county, etc. With that also, there is a huge difference about the availability of testing facilities and hospitals that even can collect those data, whether the negative results are retained or not, whether demographics are collected only, and in fact, it's been shown that non-white patients typically disclose information about their ethnicity and race at a much lower rate unless it's mandatory, and in COVID cases it is not. And in our own state of Ohio, we have better information about urban populations, but it's not clear that within urban populations it's the same versus rural, and it's true for most of the states. So the second source of bias is how we measure bias and fairness, you know, there's the equality versus equity, but the legal definitions start with fairness of process versus fairness of outcome, and most of the algorithmic solutions follow that dichotomy. There are currently about 5 roughly different classes of measurements of bias and fairness in algorithm design. In the context of machine learning especially, and there are many subclasses. So currently I think there's 22 or 23 measures. I'm sure there will be more by next week. And so, choose your own measure and the performance will be different according to that measure. And then, the algorithm design and how we measure the performance is of course the big source of bias. Even if the data are not biased to begin with, how we choose what algebra we choose to put in and how we choose to design the objective to create the objective and the matching between input and output pairs and how we measure the performance all play into the bias of the algorithm itself. So this case of Google photos identifying black faces as gorillas, clearly the algorithm was not trained. There was no input-output pair in the training data that had black faces and gorillas as a match to tell the algorithm. And this is just an algorithm making a mistake, right? Misfiring the algebra glitch. And there is an error. And it might be not the only error. There might be other errors where instead of like hubcaps, it says it's a clock, or identifying cats as tigers, or there are many other errors, but this error is special. And even if the overall error rate of the algorithm, some errors are more special than others. And the fact that, in fact, for many face recognition algorithms, the errors, however small, are biased towards darker faces. The problem also is how that is fixed. So Google fixed its racist algorithm by removing gorillas from its image labeling, classification altogether. So again, it's a choice of algorithm design and performance measure. For health outcomes, there's the famous case where software used for predicting health conditional, the risk of health conditions is typically the proxy for insurance companies that's used is the cost of healthcare. And while the cost of healthcare for Black and white patients is comparable, turns out the risk, it's not even distributed in the same way for the risk of healthcare, with the chronic conditions. So for the same set of chronic conditions, for the same medical state and health state, white patients typically receive more costly care. which means that they will be referred to screening with milder conditions than Black patients. That is the software that's used by, so the sicker Black patients will have to be sicker to be algorithmically flagged to be referred for care than the white patients, because the wrong proxy, the wrong measure was used, even though the algorithm was absolutely correct as designed. 200 million patients were part of that, the results, the outcomes of that algorithm. And the next sort, even if the data are correct and the algorithm are correct and unbiased and fair in every possible way, which is impossible, the use of algorithm creates additional source of bias. So facial recognition is wonderful when we can use it to identify our friends and family and group our photographs to quickly search for all the photos that we have of our best friend. However, the same software used to identify protesters and arrest them is a completely different, creates a completely different set of biases, right? When we use healthcare outcome predictions to improve healthcare, and this is an example from our own colleagues at Wexner Medical Center, which use healthcare prediction and machine learning to predict adverse surgical outcomes. However, you know, when similar healthcare outcomes software coupled with a patient's payment history is then used to predict the patient's ability to propensity to pay to improve collections, that may be questionable. So with that, as we use algorithms more in every aspect of our decision making, and as bias it is possible at every stage of the process, from data collection to the use of the outcomes, I think it is important to both ensure that the process is transparent and participatory, so that those for whom the algorithmic decisions are made are not only data providers and passive data providers at that, but are participants at every stage of the process of that algorithmic decision making. And only then, I think, we will be able to create trust in the process and in the outcomes and decisions of that process. Thank you. And with that, I will pass the baton to Sean.
All right, good afternoon, everyone. Very excited to deliver some remarks on this especially important topic. As has been shared, I am currently an assistant professor. I recently joined the Moritz College of Law. I have a forthcoming publication in the UCLA Law Review related to some of the subjects that I will talk about today. So my general concern when we discuss risk assessment instruments is that there are significant technical elements that we absolutely need to address when we think of execution, but routinely we don't pay sufficient attention to the structural and historical context in which we need to understand both the criminal legal system as well as the adoption in turn to risk assessment instruments within the criminal legal system. So my comments will primarily focus on the use of these instruments within the criminal legal process. So I want to start with a bit of relevant historical context. So first off, risk assessment has ultimately been a part of the criminal legal system since at least the 20th century. According to scholar Bernard Harcourt, it was first formally adopted in 1935. This was when an Illinois parole board began using a scoring system that had been developed by a sociologist, and they were using that scoring system, actuarial risk assessment, to make decisions about release for those who were incarcerated in prison. But we should understand that this turn to risk assessment in the early 20th century it was preceded by the rise and formation of the convict leasing system. And that system was one in which newly freed African Americans were targeted and arrested for petty offenses, rushed through criminal proceedings in the loosest context, no due process, no representation, and then they were subsequently leased out to private companies, individual landowners, and cities and towns to work off their debt. And so this convict leasing system, to give you an idea of the sheer amount of revenue that was generated in Alabama in 1883, only about 10% of the state's total revenue came from convict leasing. But by 1898, 73% of the state's total revenue came from convict leasing. So a tremendous increase, and further evidence that right, this convict leasing system was very much intended to exploit Black labor. To justify this new system, politicians and academics alike argued that Black people had a propensity for crime and violence, that their overrepresentation within jails and prisons was due to their inherent dangerousness and was necessary to protect white communities, particularly white women. So this convict leasing system lasted until the 1930s, when we then see the rise of actuarial risk assessment. And at that time, statistics were used during this period to confirm the beliefs that had been generated during the convict leasing system, namely that the poverty of Black communities and their overrepresentation in jails and prisons was due to the fact that they were genetically predisposed to commit crimes and engage in violent behaviors. So it's this context and this history that we should have in mind when we look at today's legal system and recommendations to continue use of risk assessment. So as many of you might have already been aware, the United States is the country with the highest incarceration rate in the world, right? We have only 5% of the world's population, yet we hold 25% of the world's prisoners. And what that adds up to is that I derived this infographic from the Sentencing Project, but 1 in 5 Black people who were born in 2001 are likely to be incarcerated in their lifetime. Juxtapose this with Latinx communities, which is 1 in 10 over their lifetime, and white communities, which is 1 in 29 white people will be subject to imprisonment over their lifetime. And so I wanted to connect this with Ohio specifically, which Ohio reflects trends that we are seeing nationally. Namely, here in Ohio, since 1970, the total jail population has increased 209%. And it's important to note, right, that jails don't merely hold people who have been convicted of crimes. Jails routinely hold people who have merely been charged with crimes and are awaiting trial. So these are presumptively innocent people. And in 2015, pretrial detainees constituted 62% of the total jail population in Ohio. So that means that people who are presumed innocent, who have not been convicted of any crime, make up the overwhelming number of jail populations. Since 1990, the Black incarceration rate in jails alone has increased 14%. And in 2015, Black people here in Ohio were incarcerated at 3.5 times the rate of white residents. We can also take a look generally at the makeup. Overwhelmingly here in Ohio, folks are on probation, but we also have a substantial number of folks who are currently incarcerated in prisons. In 2018, there were about 50,000 people in the Ohio prison system. My family is from a small town or a mid-sized town here in Ohio, Springfield, Ohio. The number of people that are currently incarcerated in prisons here in the state is about the size of the town that my family currently resides in. So with that said, there are ultimately 2 ways for us to understand both the criminal legal system as well as continued reliance on risk assessment instruments. So I'm going to break this down into what I call a dominant attitude and an alternative attitude. So the dominant attitude when we talk about the criminal legal system is that we primarily have a problem of a few bad actors. And this messaging is communicated by our courts, by our legislators, and by popular media. So the problem is the individual police officer who intentionally targets and assaults an innocent Black person, the prosecutor who is intentionally striking jurors of color for trials, the judge who intentionally punishes Black defendants more harshly than white defendants. But all of these circumstances are exceptions within this dominant framework. Generally, the criminal legal system is correlated with the protection of public safety, and there are unconscious biases which explain why Black and Latinx defendants are overwhelmingly represented in jails and prisons. So when we adopt this dominant attitude or this dominant framework, risk assessment instruments seem like a logical and effective solution. They utilize computer algorithms, as other panelists have already shared, which are routinely presumed to be unbiased in order to make determinations about release decisions, thus ensuring that the intentional bad actor cannot engage in racially discriminatory decision-making. These instruments are also considered logical because in the context of pretrial decisions in particular, where a judge is assessing whether to set bail on someone's case, the larger thinking or the predominant thinking is that these instruments will discourage the over-reliance on monetary bail by supplying judges with accurate assessments of a person's dangerousness, so that judges are only detaining people not merely because of an unfounded fear of future dangerousness. And then finally, within this dominant framework, pretrial risk assessment instruments are considered to supply us with data that can help us locate where unconscious biases are influencing determinations within the criminal legal process. So this is one manner in which we can conceptualize both the turn to risk assessment as well as continued reliance. But there is an alternative attitude towards the criminal legal system that has been surfaced by a host of scholars, but particularly has been surfaced by today's social movements as well as social movements of the past. And these, this alternative attitude ultimately points to the fact that the criminal legal system has routinely been a means of mediating conflicts that arise around race and class. So we see this starkly in the context of the convict leasing system. The Civil War not only led to the financial ruin of the South, but it stood to completely undermine a system premised on white supremacy and the of Black people. So the criminal legal system in that context became essential for resolving these problems around race and class. Convict leasing became the new avenue for exploiting Black labor for profit, while also keeping African Americans in poverty and bound to exploitative contracts such that they would remain a subordinated class of people. And this phenomenon is not merely restricted to the post-abolition period. This phenomenon continued into the latter parts of the 20th century. Namely, expanded civil rights stood to upend a system premised on the subordination of Black people. During this time, both Democratic and Republican administrations, from Lyndon Johnson to Ronald Reagan, invoked established beliefs about Black criminality to greatly expand the carceral system and increase the severity of punishment. Just like during the convict leasing system, criminal laws and policies were essential to reversing improvements in the standard of living for African American communities and also mediating conflicts around race and class. During this particular period, as the state is engaged in this evisceration of the social safety net, on the one hand, putting white economic security in jeopardy, we also see the construction of prisons and jails, which supplied new revenue streams, new employment, particularly jobs as corrections and court personnel. So the problem then with the criminal legal system is how it both generates beliefs about Black people having a propensity for crime and how these beliefs facilitate and normalize profit being drawn from the caging of human beings. When we analyze risk assessment instruments in this context, it becomes evident that these tools are doing very little to unearth this larger phenomenon and in fact are following historical trends. One, the biased data that they use will inevitably recommend more severe measures for Black defendants than for white defendants. further cementing beliefs that Black people have a propensity for crime and violence. And second, the tools encourage and require continued investments in the criminal legal system, diverting funding from meeting people's needs and ensuring continued growth in prisons and in jails. And so I wanted to wrap up my remarks. Across the country, we are witnessing, particularly in the context of bail, a very rigorous debate that has unfolded around pretrial risk assessment instruments and utilizing these tools to move us away from this over-reliance on incarceration in the context of jails and pretrial detention. And so here in Ohio, the Ohio Supreme Court recently issued some recommendations to the legislature and have received a good deal of positive attention because those recommendations did not include pretrial risk assessment instruments. However, it's important to note that these tools are already in use across the state and that there is nothing that is actually prohibiting their continued use. This should raise serious concerns for folks who are committed to racial justice. Simultaneously, even where the tools are not being routinely used, we should continue to engage in an analysis and a critique of a host of criminal policies and how they contribute to normalizing the disproportionate incarceration of Black and Latinx people. So I very much look forward to questions if time permits, but I will now pass over the remarks to Chris Stewart.
Allow me to share my screen and say that today, my talk should follow nicely with Sean's. I will talk about intent, incentives, and inequity. In particular, I bring a background as a coder. So over time, I've built a lot of different types of systems. And coding is sort of ingrained in my blood. I've been doing it since I was very young. So I tend to see code and algorithms all around me. Building on what Tanya said earlier, to me, algorithms are just step-by-step procedures that allow you to do some task. But algorithms not only allow you to do a task, they have these distinguishing properties. And these distinguishing properties are important because that's how we choose between competing step-by-step procedures. Anyone that's used YouTube today knows that I can go on YouTube and find at least 12 different videos that tell me how to shoot a jump shot. How do I pick one, or how to cook a dish? I'll talk about intent, and here I don't mean intent in the classic philosophical mindset of one's heart, but I mean it more from a programming perspective. When you do Android programming, intent is something that you use to specify goals, to allow you to specify exactly which type of algorithm you want the system to go down. I may say for my search app in an Android program that one of my intents is to only use Google search, or I may say my intent is to use any search that provides a fast enough response. My argument today is that when we talk about algorithmic bias, it is very important for us to focus on those intents, and that is those goals that we're prioritizing from the algorithm. The reason for that is that algorithms tend to change over time. We decide that we want to do different things, or we find better ways to do the things that we're already doing, in part because very smart people will find ways to change the steps to optimize and improve our realization of our intents. However, the intents themselves are stubbornly persistent. And an argument that I'll make here very concretely is whenever we're talking about averages or average case behavior, intents can lead to really can incentivize short-sightedness and lead to long-term problems. Just to make a link with the previous talk, I think the criminal justice system is a really great example of this. The average person does not encounter prison confinement in their lifetime. So if you're talking about a system that works well for the average person, you've already won. But instead, the problem with average is, just as I'll show here, you end up making weird trade-offs because you're able to hide really bad events inside of this average. So as a code builder, if you were building internet services in the mid-2000s, one thing that you probably believed was that you needed to minimize the average response time. That is the time that it takes for a person to be able to click again on your website. And this leads to myopic incentives. So we've discovered over time. So there were widely used open source software packages that made this perplexing decision. Hey, if you have a big shopping cart, it takes a long time to load that shopping cart for an e-commerce site. So let's prioritize all of the users that have small shopping carts to improve average response time. Clearly, this is a bad idea because you actually make your money on an e-commerce site from those large shopping carts. So some folks at Google, Jeff Dean, Luis Barroso, Partha Ranganathan, these folks have evangelized a better way in Google to think about building these types of services, which is to focus on the queries, the users that are facing headwinds and are falling into the 99.9th percentile response time, as they call it, or the tail latency. The point here is those headwinds, if you're fixing things for the folks that are facing those headwinds, you're making gains that affect the whole system. Let me reintroduce myself. I am a diversity and inclusion guy. I'm the chair of the Diversity and Inclusion Committee in the CSE Computer Science Department. I previously was the advisor for the Group on Women in Computing at OSU, which is a nationally recognized group, outstanding leadership there. They are outstanding leaders, I just helped them. I've done outreach and developed projects to help with STEM education, especially for diverse groups that have reached over 2,000 students here in the Ohio area alone. I'm regularly on grad admissions committees, and I can say in this context, computer science and data science still use average-based intents far too often. We tend to prefer the grade point average over holistic evaluation. We tend to prefer the average score across standardized tests over internships, research experiences, real-world passion for what people do. And this leads to all kinds of myopic incentives that have ultimately made it impossible for us to really diversify the field. Sadly, the percentage of African Americans graduating with a PhD in computer science has remained flat since before I came to grad school, and we have little movement today that suggests anything will change. So we're trying to make some changes in my department. We're trying to move beyond looking at things like the average graduation rate to begin to consider things like intersectionality. For a time, I'm not going to go into intersectionality. I encourage you to look up the writings of Bell Hooks for that. I'll just say what we're really trying to do is target the folks that are facing the strongest headwinds empirically, and make sure that we only judge our success based on the graduation rates of those that are facing these intersectional challenges of bias and discrimination. And with that, I hope I left time for us to have questions from the audience.
Well, that was really interesting. Thanks to each of our four speakers. I want to just take a minute to ask Doug McCulloch from Black Tech Columbus to just say a few words about his organization right here in Columbus and very related to these topics.
Thank you, Dennis, and thanks to all the speakers. It's fascinating stuff. I'm Doug McCulloch, and Black Tech Columbus was formed to create an authentic space for Black technology professionals to connect, collaborate, and create. And we're in total support of these kinds of things and hope that the community can engage and interact with some of these questions. And I think that if you look at all four presentations, we're really getting to what where we need to be going. The one ask that I would make of all of us as we evaluate solutions here to the question of dealing with racial bias and algorithms is who's in the room? And by that, I'm talking about the kind of diversity that Christopher just spoke about. in terms of how do we diversify the teams and the experiences and even the experiments. And the second question is what kind of use cases are we actually trying to solve? And I think when we ask ourselves those two questions, we can find the human element. And I would ask all of the panelists and the people asking questions to leave that question just sort of on the table as we find what we can do about the algorithm and those things. Who are the people who should be in the room as we are designing these experiments and coming up with those kinds of use cases? Because I think it has a big influence. If we had complete diversity on these teams, we would still have bias, because bias comes from us as human beings. But I have to believe that we need to expand these fields with professionals so that we can work on this problem. So once again, thanks to everybody. Black Tech Columbus wants to continue to be a part of this conversation. Thanks.
Thanks, Doug. Thank you, Doug. We only have a few minutes, and we received some really interesting questions in the Q&A, so I'm going to combine two of them for our panelists. One person, because they both kind of get to what's the potential of algorithmic decision-making here? Does it have any potential in this area? So one questioner asked, how do the panelists respond to Sendhil Mullainathan's comment that, quote, biased algorithms are easier to fix than biased humans? And the second related question is, you know, we heard about bias throughout the life cycle here. Do you have any examples of an algorithm that was developed based on equitable principles and could be an exemplar of how to do this well? So Kelly, why don't I ask you to lead off, and then others can join in.
Great. Thank you, Dennis, and thanks for the great questions posed by the audience. I'll try to speak as quickly as possible. So I really like the question about Dr. Mullainathan's comment, specifically because this actually addresses one of the comments earlier, using his study design from, I believe it was 2004, looking at Black versus white sounding names is actually one of the ways that we can use algorithms to actually police and identify when bias is occurring. So that's just one example of how these can be used in practice. But in terms of that quote itself, are they easier to fix than humans? Well, you know, I can understand that premise. Certainly, as we've talked about with the entire life cycle, there are more opportunities to kind of think through and create potential fixes for when bias exists. So yes, I can agree with the premise that an algorithm is more malleable than a human decision maker. But in reality, if we're going to go back and to correct for some sort of discrimination that's already occurring, then you have to have a whole host of other decision makers that are involved with that process of correction, first and foremost. And then you have to know that they have to even be aware that there is a problem. And oftentimes, as other presenters alluded to, they might not necessarily be aware. So it's the lack of ability and transparency for where those checks are actually built in that makes them so insidious.
And then I would just add, absolutely agree with Kelly's comments. But one, I think what I'm hoping to raise is, I think first there has to be an agreement about what constitutes bias. And this is not easily resolved. And I think that is the deeper underlying problem. If you're adopting the instruments and there are conflicting perceptions of what constitutes bias, there are reasons that select definitions are going to be elevated over others. And I would just add, in the context of the criminal legal system, where we're seeing the adoption of the instruments, they're specifically being cast as a mechanism to improve the decision-making of subjective actors rather than as a substitute. And within the criminal legal process in particular, there are due process requirements that have to be met, which make it nearly impossible to have the instruments themselves wholly substituted for the discretion of the decision maker. So I think that, yes, the premise could certainly be accurate. There are a good deal of scholars who have made the argument that we're able to at least perceive biases in different ways as a result of the instruments. But I think there is still the unresolved issue of what exactly constitutes bias, whose definition should be elevated, and then also exactly how do we intend these to influence or replace or dictate the decisions of subjective actors.
Folks, I am told that it's 1 o'clock and we have a hard stop here. I know that we could engage in this conversation for a much longer time. As Doug said, let's keep this conversation going. Please, follow up with our speakers with the program on data and governance. We look forward to continued discussions about these and other really important issues. And thank you very much for joining us today. And please join me in thanking our speakers, all of you. Thanks very much.
Thank you. And please join us also at the Translational Data Analytics Institute's community of practice on responsible data science, and watch for other events related to responsible and just data.